So we're actually using Laplace transforms for the reason that we started studying them. So to kind of recall here the big picture, we're going to have our initial value problem here in the time domain. And then we're going to Laplace it over to get an algebraic problem in the S domain. Okay? And once again, one of the potential project ideas, if we think of t as time, we've been calling this a frequency. It's actually a complex frequency. To talk about what this variable is doing and then tie this back into Fourier transforms. Okay, so that'd be a nice project. Anyhow, once we get it over here into the S domain, we solve the algebra equation, and then we use the inverse Laplace to bring it back. And so the key formulas that we developed yesterday, the Laplace transform of the derivative, we'll call that capital Y minus y at 0. So this is why we need the initial conditions. And we derived this using the integral definition. And then we iterated that. So we took the Laplace of y double prime, we applied this formula to y prime, and then applied the derivative formula. Oop, there's an s here, I forgot. It's sy minus y at 0. This is s squared y minus sy at 0 minus y prime at 0. So once again, that's where we have initial conditions. If the differential equation doesn't provide the initial conditions, then we would just carry those constants through. And then our final answer would have those coefficients in there, not unlike when we would have the C1 and C2, and when we would do things like in chapter 5. Right? So these are the basic things we learned yesterday, and we did some examples. So let's take a look at this one. So we've got y double prime minus 4y prime plus 4y equals 100 sine of 4t plus at plus 4, and then we got our initial conditions. And once again, it might be good, something you could do in the privacy of your own home. This is something that we could actually solve with chapter 5. This would be a classic method of undetermined coefficients problem that you could do. But we're going to use Laplace transform. Okay, so step 1 is to Laplace everything. All right, so we're going to Laplace the left-hand side. And then we'll Laplace the right-hand side. And so here we go. Okay, so the Laplace of y double prime, that's going to be s squared times the Laplace of y, which we're calling capital Y, minus s times y at 0 minus y prime at 0 minus 4 times the Laplace of y prime. So it's s times Laplace of y minus y at 0 plus 4 times the Laplace of y. So we're getting s squared Laplace of y minus s times y at 0. So I'm going to just put this up here for y at 0 is 8, y prime at 0 is 9. So it would be minus 8s minus 9 minus 4s Laplace of y plus 4 times y at 0 plus 4y. So let's get everything involving the y. We can factor it out. So I've got s squared y's there. Minus 4sy. Plus 4y. So s squared minus 4s plus 4 y. And let's see what else we've got here. We've got a minus 8s. And then plus what? We got 32, 23? So let's take a minute and make sure that all tracks with your calculations. So far, so good? Well, that's enough for me to keep going. All right. Now let's look at the right-hand side, the Laplace transform of no worries, Aaron. I'm just having fun here today. I'm normally not at school this early. Okay, I'm going to take Laplace of 100 sine of 4t. Whoops. Plus at plus 4. All right. Okay, so once again, we can use linearity here. That's going to be 100 Laplace sine of 4t plus 8 Laplace t plus the Laplace of 4. Now 100 sine of 4t, we've got the regular circular functions here, sine and cosine. So they are going to give us squares in the denominator, in this case a sum of squares, so it's going to be 100 times. The frequency here is 4. That's going to be s squared plus 4 squared. And since this is the sine, we get the frequency in there in the numerator there. What's the Laplace of t? Good, 1 over s squared, so that's going to be 8 over s squared. And then the Laplace of 4, that's 4 times Laplace of 1, so that would be what? Four over s, good. Okay, so we get 400 over s squared plus 16 plus 8 over s squared plus 4 over s. All right, now let's look at the whole diffie-q then, all put together. So we've got s squared minus 4s plus 4, all times y. Minus 8s plus 23 equal to 400 over s squared plus 16 plus 8 over s squared plus 23. Whoops. No. Plus 4 over s. Okay. So now the goal is we want to solve this for the Laplace of y. So we're going to solve this for capital Y. As usual, we have a linear equation in the variable y, which means we can get all the y stuff on one side and factor it out, which is what we do. So there's that. We'll move everything else to the other side. So s squared minus 4s plus 4 times y is going to be equal to all of this. I'll add the 8s over and subtract off the 23. And so to solve for big Y, I got to take everything on the right-hand side and divide it by what? Yep, s squared minus 4s plus 4. So here's what y is equal to. Now just to save us some time here, we know that we're going to be doing partial fraction decomposition. So just so we don't have to write all of this over and over again, we're going to have to end up factoring this anyway, right? So how does this happen to factor? Does it factor nicely? Yeah, it's s minus 2 quantity squared. So each of these is going to pick up a factor of s minus 2 quantity squared in their denominators. So y equals, the first term is going to be 400 over s minus 2 quantity squared times x squared plus 16 plus 8s squared no 8 over s squared. This is where it helps to have a big chalkboard in front of you. Plus 4 over s times s minus 2 squared plus 8 over s, or 8s over s minus 2 squared minus 23 over s minus 2 squared. So I'm just going to take a quick double check to make sure I didn't lose anything. Going from slide to slide. This is another reason why I'm trying to take a break from this sort of class. It's just getting... do that. Okay. All right, now it's, you know, some folks like to get common denominators and just do the partial fractions. Other people like to do the partial fractions and then add all stuff up at the end. You know, these have the same denominator, so okay, it might make sense to look at this. Maybe combine these, but these other ones have different denominators, right? Now you could say, well, this one isn't that far off, but I mean, you know, at this point, what we got to do is we got to go in, we got to do partial fractions on these things to get them to all work out. So maybe we'll just combine these two. You know, it's whatever you want to do. These are sort of naturally, they naturally go together. They got the same denominator. But you can see that, like, these three terms here are going to all have the same kind of decomposition. So, I mean, you know, it's not a bad idea to actually combine all these three, but I try to usually do what I've seen students do. So let's go ahead and start off with this big one, the 400 over s minus 2 squared times s squared plus 16. Because that's sort of the one that's got this different factor in here. And we got to write this out. So we start off with the partial fraction, the form of the partial fraction decomposition, which would be what here? Yep. So you'd have an a over s minus 2 plus a b over s minus 2 squared, because that's a linear factor, that's a repeated linear factor. And then this is an irreducible quadratic. S squared plus 16 has non-real roots. So that would be your cs plus your d. And now we can go ahead and clear denominators to get us our equation that we can start working with. So if I clear denominators, I multiply the first term by s minus 2 quantity squared, s squared plus 16. One of those s minus 2 quantities will survive, and then the s squared plus 16 will. On the b term, the s minus 2 quantity squared is completely gone. And then on the cs plus d, the s squared plus 16 will cancel out, and we get the s minus 2 squared. And so now we look at this and ask ourselves, is there a value of s we can plug in that'll help us quickly obtain one of the coefficients? Yeah, s equals 2. Yep. Yeah, and we're going to stay away from imaginaries. But yeah, you're right, Zoran. You could plug 4i in there if you wanted to. We'll stay away from that. We'll plug in the s equals 2 here. Even though technically speaking s is a complex frequency, we'll stick to the reals here. S equals 2, you got 400 on the left-hand side. Everything's going to cancel out that's got an s minus 2 in it. So that would zero out. This would zero out. So I'd just be left with b times 2 squared plus 16. What would I get for b then? $20. Okay. Now to get the a and the c, I have to, or a, c, and d, I got to look for a coefficient. So now I got to equate coefficients of the powers of s. Okay. So let's take a look. On the right hand side, the highest power of s that's going to come out of any of this is going to be what? S cubes. So let's look at s cubes. On the left hand side, there's no s cubes at all. What would produce an s cubed over here? I'd have a times s squared. So I'd have as squareds, or as cubes rather, from the first one. Would I get any bs cubes? And then I'd have cs times s squared. That would give me cs cubed. So it'd be a plus c s cubes. Now let's just go down the line. Let's get s squareds. So if I look at the first term here, how many s squareds would come out of this if I multiplied this out? Yeah, minus 2a of them. So you'd have, well, there's 0 s squareds on the left-hand side. I have minus 2a of them from there. Plus, how many s squareds would come out of this multiplication? B of them. Here, how many s squareds would come out? So you might want to, yeah, very good. So it might help to if you FOIL this out, you'd have s squared minus 4s plus 4. So minus 4s times cs would give me minus 4 cs squared. And then you'd have the s squared times the d, so plus d. So here, this equation's got everything in there. Now let's look at just s's. If you multiplied this out to get just s, you'd have a times s times 16. So I'd have 16. So once again, there's no S's on the left-hand side. You have 16A of those. Any S's coming out of here? No S's out of there. What about here? Once again, maybe what we'll do is we'll just go ahead and FOIL this out just to help us see better. So you'd get minus 4D, but also 4C. So 4D minus 4C. And then finally the constants. But we already know that B is what? B is 20. So that should be the same as what we get for the constant. So now we just start plugging this stuff in. So I know that A plus C is 0. That's our first equation. I'm going to plug in B as 20. I have minus 2A plus 20 minus 4C plus D is 0. And then 16A plus 4C minus 4D is 0. So there's systems of equations. And then you solve this using substitution elimination. What do you get from number 1 here? So number 1 tells you right away that C has to be what? In terms of A, C is the opposite of A. So let's plug that in to 2 and 3. So I got a minus 2A plus 20 minus 4 times minus A plus D is 0. So now I got this equation, then I got 16A plus 4 times minus A minus 4D is 0. So the top equation, I got minus 2A's plus 4A's, so that gives us 2A's. Plus D and I guess that's equal to minus 20. And then I'd have 12A minus 4D is 0. And I suppose this one right here, I can solve that one pretty quickly. I can get D here pretty quickly. D is going to be what in terms of A? (3A). So I can plug that into there. So there's 5A is minus 20. So A is minus 4. C is the opposite of A, so C is going to be 4. D is 3A, so D is going to be minus 12. So we put this all together, and we've got the partial fraction decomposition of this thing. So 400 over s minus 2 squared times s squared plus 16 equals a over s minus 2 minus 4 plus b over s minus 2 squared, that's 20, plus cs plus d over s squared plus 16 Oops, where did it go? I lost it. C is 4, so 4s minus 12. All right, so that's the first partial fraction decomposition done. All right, so we'll come back to this in a minute because now we have to inverse Laplace it. Okay, so now I just move on to the second one. All right, going back here, the second partial fractions we got to do. So once again, you're looking at these three terms here. They're all going to have s's and s minus 2 squares. All right, so once again, it's up to you. Let's go ahead and get a common denominator here first, and then just do the partial fractions once. You can do them individually like we did yesterday. Things will cancel out, but let's just take a look at adding these fractions together and then doing the partial fractions. So we've got 8 over s squared times s minus 2 squared plus 4 over s times s minus 2 squared plus 8s minus 23 over s minus 2 quantity squared. So we're gonna, it looks like we're working against the grain here because we're gonna be getting a common denominator and then breaking it up again. But the reason is I could do partial, each of these would require partial fractions. They all have pretty much the same denominator. Let's just write them as a single denominator first. And so hopefully at the end we've only done one more partial fractions instead of 3 more. Okay, but it's up to you how you want to do it. So like on the first one here, I have everything I need. Got the full denominator here. For this denominator, I'm only off by a factor of s. So that's not going to be that big of a deal. And then here I'm only off by a factor of what? What I have to multiply this by to get that denominator. Yeah, the s squared. Oops, 8s cubed minus 23s squared. So let's just look at partial fraction decompositioning this, right? So and this is one of those things where experience is the best teacher on this. But I am aware this is mentor. Zoran, you leave early today, right? This is an early day. So I'm trying to get this done here in what, 10 minutes or whatever. Okay, here we go. We got repeated linear factor a over s plus b over s squared. Repeated linear factor c over s plus 2 d over s minus 2 squared. Clear the denominators. 8s cubed minus 23s squared plus 4s plus 8 equals a times s minus 2 squared, b times s minus 2 squared, c times s squared times s minus 2 plus d times s squared. And now we look for values of s to plug in to help us get coefficients. Yeah, 0 and 2. Plug in s equals 0. On the left-hand side, plugging in s equals 0 would give us 8. On the right-hand side, the a, c, and d terms all drop out. I'd be left with b equals what? B equals 2. Very good. And s equals 2. You plug that in. The a, b, c all cancel out. I plug 2 into the left-hand side. We got a little work to do here. What would I have if I plugged in s equals 2? You'd have, what, 64 minus 4 times 2. Is that that's 92? Plus 8 plus 8. And so you get what? 16. So negative 12 would equal, yeah, 4d. So d would be what? Negative 3. All right, so we got 2 right off the bat. Now we can just equate coefficients. So let's look at s cubes. On the left-hand side, I actually have some s cubes. I got 8 of them. On the right-hand side, what would I get for s cubes? I'd get as cubes here and cs cubes there. So there's the a plus c. And those are the 2 that I need. So what else would have an a plus c? Let's look at s squareds then, because I just need 2 equations at this point. Now, once again, if you need to, feel free to FOIL out this s minus 2 squared. You'd have s squared minus 4s plus 4. So how many s squareds would you get out of this one? Yeah, minus 4a. Oops, what's the s squareds? Here I got minus 23. Oops. You'd have the minus 4as squared, and then you get a bs squared, a minus 2cs squared, then you got your ds squared. But we know b and d. You got that. So, right? So you get as minus 4as squared here when you multiply that out. You'd have an s squared times b, a minus 2cs squared, and then a ds squared. But b is 2 and d is minus 3, so I can plug that in. From the work we did here. So we put all this together, I get an a plus c is 8, and 4a minus 4a minus 2c, this would be what? Minus 1 equals minus 23. So minus 4a minus 2c is minus 22. So this one says that c is going to be what? Minus a. So let's see here. So c is 8 minus a. So I've got minus 4a minus 2c is minus 22. So minus 2a would be what? Whoops, minus 6. Is that right? And then so a would be 3 and c would be 5. So now we go back to the partial fraction decomposition. 8 minus 23, 4, and 8. So 8s cubed minus 23s squared plus 4s plus 8 over s squared times s minus 2 squared is equal to this, a over s, so 3 over s plus b over s squared plus c over s minus 2 This is why, once again, it's nice having a board. Plus d over s minus 2 squared. What was d minus 3? There's a minus in there somewhere. Okay, this is the second piece now. We got to inverse Laplace. All right. Okay, now here we go. We just got to take everything back. So the function we care about, little y, is the inverse Laplace of big Y. So now we're just going to go through and inverse Laplace everything. So here we go. Ready? Let's go to the first red rectangle. Ah, where'd it go? Goodness. Must be later on then. All right, let's inverse Laplace all of this. Okay, so let's just do this here. Let's inverse Laplace. What's the inverse Laplace of minus 4 over s minus 2? Minus. Oh, yeah, I got to. Oh, okay. All right, Zoran, we'll finish this up, and then that'll be it. So that's minus 4 e to the 2t. This, you'd have to use that shift. You bring out an e to the 2t, and then multiply it by inverse Laplace 1 over s squared. So minus 4e to the 2t plus 20t e to the 2t. And then here you would break this up. That would be your 4 cosine 4t. And then you'd have your minus 3. Oh no. It's the worst time for this to happen. Minus 4 cosine 4t. And then here you'd have your minus 12 inverse Laplace of this. You'd have minus 12 over 4 minus 3 sine of 4t. So there's your sines and cosines coming out. And then you'd have to add all of that to the inverse Laplace of the other big red box. So 3 over s, that's going to come back as a 3 plus your 2t plus your 5e to the 2t. And once again, this would be your shift. You've got the s minus 2 in parentheses. So like we talked about last week, that'd be minus 3 e to the 2t inverse Laplace 1 over s squared. That's your minus 3t e to the 2t. So if we've done everything correctly, right, which we've spent, what, 45 minutes on algebra here, at least, we should be able to get our final answer. So let's see if we can get our final answer, and let's see if it matches. So y of t equals all of this, 3 plus 2t plus 5e to the 2t minus 3t e to the 2t. And now we got to go back and find that other one. I think we have to go ahead then, right? Because of slides. Minus 4e to the 2t This is so frustrating for me. So minus 4e to the 2t see if I can just remember. If my memory were any good. 20 and then 4 cosine minus 3 sine. Okay. Plus 20t e to the 2t plus 4 cosine 4t minus 3 sine 4t. And you look at, see what you can combine here. So it looks like we can combine these. And we can combine these. So the final answer should be 3 plus 2t plus e to the 2t plus 17t e to the 2t plus 4 cosine 4t minus 3 sine 4t. And it'll be a minor miracle if this actually matches. Once again, when you're working this out on paper or board, you have an advantage of not having to flip back and forth. Let's see how close we got to the answer on here. E to the 2t, got that. Just check these off as we go. So we got that. 17t e to the 2t. There we go. Minus 3 sine of 4t. There we go. Plus 4 cosine of 4t. There we go. And then 2t plus 3. Look at that, Rick. How about that? Whew!
I never got that.
Well, I got all tripped up because. Oh yeah. But these that's the. Like I said, I used. Like this would be one of those problems where you'd start on the left-hand side of the front board and you would finish on the right-hand side of the sideboard. You know.
Yes.
But.
You're right. If you're able to look back and forth, it goes a lot quicker.
But to be fair, this has been your experience pretty much in all calculus. It's like over 90% algebra, you know. So. Anyhow, are you in the library, Rick? Are you on campus? I'm heading over to the library.
The second floor study area.
Oh, okay. Yeah, if you wanna pop up between, I'm gonna be over there till like 1 o'clock, just hanging out with ballots.
Where are you?
In the library. I'll be in the library. They'll be like having a voting. Okay. So you can just pop in if you want. Otherwise, have a great rest of your day. And tomorrow we'll start talking about unit steps, heaviside functions. Should be fun.